Okay, hello everybody. Today I am actually going to analyze Stephen's lever launcher experiments. It's been a few years, but I'm going to do it. I know he also analyzed it himself, but I'm going to analyze it with a software tracker, and I'm interested how it would analyze all the trials. So Stephen has done multiple trials, and he has some super slow motion footage and the normal slow motion and some real life footage. Now the problem with the super slow motion footage is that there are a lot of dead frames, like 3, 4, 5 dead frames per little bit that the ball moves. And then for the normal slow motion there are always 2 or 3 dead frames. And I figured that with the normal real life footage there are no dead frames, so that those are the best trials. And so we will have 3 trials for the 1 mass ball and then 3 trials for the 1/2 yellow billiard ball. So this is the 1 mass trial 1, and I'm going to now add a new track. All right, I'm going to zoom in a little bit. We're going to track the top of the ball here each time, like that. I'm going to try my other best to always track the top of the ball, like that. Okay, over here, and then hop, here we go, and now we have reached the end. So that's going to be our first trial. Then the next one, hold on, I'm going to go back a little bit. I'm going to have to add another track. There we go. Zoom in a bit. There we go. And one more. And that's it. So this is trial 2. I'm going to turn this into a velocity magnitude graph. Then the third trial. Okay, there we go. We need to add another track. Here we go. Come on. There we go. And then one more. Right. So now those are the 3 trials of the 1 mass. There we go. Then we go to the half mass. Oh, gotta go back. Right. Then we add another track. There we go. And then we start tracking the top of the ball. It's a little bit vague, but I can still see the edge pretty much. We are already at the top, and there we go. Turn that into a velocity graph. All right, second trial. Oh, it goes really fast. Hold on. No, this one I already tracked. All right, there it is. Next trial. Okay. And there we go. Okay, and then the last trial. Whoa, go back. Yes. Add the new track. Here we go. Zoom in. Okay. And then the last one. And there we go. It's only a couple of frames. So now we have all the graphs. So we go to the first one. The 1 mass, which has a maximum velocity over here, right at the top, and we can see on the left corner what the number is, 4.68, and we're going to write that down over here, trial 1, 4.68, right? Then the second trial has a maximum velocity of 4.89. 4.89, like like that. Then the third trial has a maximum velocity of, what's that? A 5.04. Okay. 5.04. Right, then the half mass has a maximum velocity of 6.9. 6.9. There we go. Then the second trial, 7.96, right? 7.96. And then the third trial, what's that? 7.08. 7.08. Right, now we have our numbers. So now what we're going to do is we're going to take the average and then divide them by each other. Okay, so I got to now grab my calculator. So we have 4.68 plus 4.89 plus 5.04 divided by 3, which is 4.87. Okay. Then 6.9 plus 7.96 plus 7.08 divided by 3, which is 7.31. Okay, so now we divide these numbers. 7.31 divided by 4.87. Let's do that. 7.31 divided by 4.87, which is 1.5. So the tracker software, well, with the tracker software we have a velocity ratio of 1.5. I know Stephen had analyzed it and he came up with 1.69. So yeah, the question is, which one is more accurate? Is it 1.69 or is it 1.5? Well, it's up to you. I'm just showing the results that the software tracker shows. I think it's interesting. All right, that's it. Thanks for watching, actually. There we go. Let me